Hey guys, welcome back. We're on day 17 right now, looking at the quotient rule, a very important rule for derivatives. So let's take a look at just the general form. Again, it's important to have the general forms memorized as well as like the application of it. Both can come in handy on the AP exam. So let's take a look at, obviously we know from mathematics that quotient means division. So taking a look at, let's take a look at the derivative of a function divided by another function. The quotient rule, when we do the derivative of a quotient, we end up with a quotient answer, which is different than the product rule. So taking a look at this, the quotient rule looks a lot like the product rule, except we change the plus in the middle to minus, and we divide it by the lower function squared. So once again, instead of thinking of first and second, right, derivative of the first times the derivative plus the derivative of the first times the second plus the first times the derivative of the second, we think of these things as top and bottom, right? Numerator and denominator. Well, the quotient rule is going to start with the derivative of the top times the bottom. So we have the derivative of the top function times the bottom function, f prime of x, g of x. And now we are going to subtract the top function times the derivative of the bottom. So again, that top part looks just like the product rule, except the plus in between changes to a minus. And we're going to divide by g of x squared. It is not g prime, it is just regular old g of x, and we have to square it. This is our quotient rule. This is the general form that we need to have memorized. Anytime we do the derivative of f of x over g of x, it would be f prime g minus fg prime over g squared. Okay? In words, there's kind of a rhyme that helps people remember this. And again, take it or leave it. If it's helpful, use it. If it's not, skip it. But in words, we have low d high minus high d low over low low. Now what the heck does this mean? Well, the low function would be g of x. D high would be the derivative of the high function. Right? And again, because of the commutative property, I can do f prime g or gf prime. It means the same thing. So there's low g, d high, f prime, minus high function, which is f, derivative of low, which is g prime, over the low function times the low function, or low squared, or g of x squared. So whichever way you prefer to kind of memorize it, as long as you have it memorized and can solve it correctly every time. Let's take a look at an example problem. I'm going to do 2 examples, and I'm going to look at a derivative we already know. why don't you pause the video here and try and find f prime of x, given that f of x equals 2x cubed over sine x. Once again, we see this thing written as a quotient, right? We have the function 2x cubed divided by the function sine of x. So we're going to treat this like in our general form. 2x cubed would be f of x, sine x would be g of x. Go ahead and try it and pause the video, come back and you'll see the answer. Okay, we're back. I'm going to go ahead and talk our way through this. So we want to start with the derivative of the top function. The derivative of the top function is 6x squared. So that's the derivative of f prime, the top. We have to multiply that by the low function. So we have 6x squared sine x. Then we want to subtract the top function by the derivative of the bottom function. So we're going to just have 2x cubed times the derivative of the bottom function, which is cosine x. We're going to divide the whole thing by sine of x squared. Generally, when we square a trig function, we write that exponent in between the sine and the x. So there we have it, 6x squared sine x minus 2x cubed cos x over sine squared. We want to take a look, anytime we do the quotient rule, sometimes we can simplify. In this problem, we can't simplify anything because we have, you might say, well, we can cancel out those sine x's. But we can't cancel out the sines because there's not a sine x in every single term. Okay, so that's f prime of x. Let's try one more example. Okay, so we have f of x equals, is the function tan of x divided by e to the x. Let's go ahead and find f prime. Once again, you can pause the video here and try it on your own. I'm going to try it as well, and we'll come back and take a look at it. Okay, we're back. So let's start this problem with the derivative of the top function times the lower function minus the top function times the derivative of the lower function all over the lower function squared. Now, when we take a look here, this is totally correct, right? F prime, right? Low d high minus high d low over low low, or we can think of it as f prime g minus fg prime over g squared. But we can simplify this a little bit. Notice that we have an e to the x showing up in all three terms. So what we can do is factor out, or we can just cross off an e to the x in all three terms. Doing that, we end up with this. Notice that there are two e to the x's on the bottom. We don't cancel the whole thing, just take out one of them. And we can write this simply as f prime of x equals secant squared x minus tan x over e to the x. Okay. I want to look at the derivative of tangent, just to look at if the quotient rule works with what we already know. So this will be our last example. We know that the derivative of tangent of x is equal to secant squared. But let's prove this using the quotient rule. Okay? So we know that, let's say f of x equals tan x. What is a way that I could write tangent of x as a quotient? Well, we know tangent of x is simply sine of x over cosine of x. what's going to happen now if we take f prime of x and use the quotient rule? Well, hopefully end up with the same answer, right? Secant squared x. Well, let's go ahead and let's execute the quotient rule on the function sine of x over cosine of x and solve this thing. Right, so I want to do the derivative of the top, which is cosine x, times the bottom, which is cosine x, minus the top function, sine of x, times the derivative of the bottom function. Well, the derivative of cosine is negative sine, so I'm going to write times negative sine x. And I'm going to divide this whole thing by the bottom function squared. Well, simplifying this thing down a little bit, I see I get cosine squared x. Notice I can throw this minus in that parentheses out front. Negative sine x times negative sine x is a positive sine squared x over cosine squared x. Now again, right now this does not look like secant squared, but remember your trig IDs. Your most important Pythagorean theorem, trig ID, says that sine squared x plus cos squared x always equals what number? 1. So we can replace the top with 1. And we know that 1 over cosine squared would simply be secant squared x. We showed. Thanks for watching. Take these notes well. Be ready on Wednesday to work on some of these product rule problems. Thanks. See you.